Welcome to the Snoozy Scientist, to tonight's journey through one of humanity's most profound questions. Whether you're a truck driver navigating empty highways under starlit skies, or you're finally settling down after another demanding day at the office, you've found your place here with us. Take a moment to comment below, let us know what time it is where you are, and which corner of our planet you're calling home tonight. If this video helps you drift into peaceful rest, a gentle like and subscribe would mean the world to us. The visuals you might see will complement our story beautifully, but they're simply there to enhance the experience. Everything you need to understand our tale tonight will come through the words themselves, so feel free to close your eyes whenever you're ready. Tonight, we're asking a question that has haunted human consciousness for generations. Are we truly the first advanced civilization to emerge on Earth? Or might there have been others before us, their traces lost to the relentless march of time? It's a question that takes us from the depths of our oceans to the farthest reaches of space, from ancient myths that might not be myths at all, to cutting-edge scientific discoveries that challenge everything we thought we knew about our past. The story begins, perhaps surprisingly, not on Earth at all, but in the vast cosmic neighborhood surrounding us. You see, when we gaze up at the night sky, we're looking at a universe that's been active for over 13 billion years. Our own solar system formed about 4.5 billion years ago. But here's what's truly staggering to consider. Stars like our Sun, capable of nurturing planets with complex life, have been forming for over 10 billion years. That means there have been countless opportunities for intelligence to emerge throughout the cosmos, long before our little blue planet even existed. But let's bring this closer to home. Earth itself has been a stage for life for approximately 3.5 billion years. During this immense span of time, our planet has witnessed 5 major extinction events, each one reshaping the biological landscape entirely. The most famous of these, the asteroid impact that ended the reign of the dinosaurs 66 million years ago, eliminated roughly 75% of all species on Earth. Yet life not only survived, it flourished and diversified in ways that eventually led to us. Now here's where things become really intriguing. If we compress Earth's entire history into a single calendar year, with January 1st representing the formation of our planet, complex multicellular life doesn't appear until late October. Dinosaurs emerge in mid-December and rule until December 26th. Modern humans, Homo sapiens, don't show up until the very last minutes of December 31st. Our entire recorded history, all of human civilization as we know it, would occupy less than the final second of that cosmic year. This perspective raises an uncomfortable question. In those vast stretches of time before human civilization, spanning millions upon millions of years, could there have been other intelligent species that rose to prominence and then vanished? The fossil record, remarkable as it is, preserves only a tiny fraction of life that once existed on Earth. Soft tissues rarely fossilize, and even bones require very specific conditions to be preserved. Most of what lived and died on our planet left no trace whatsoever. Consider this thought experiment. If our current industrial civilization were to disappear tomorrow, what evidence would remain of our existence after, say, 10 million years? Our cities would crumble and be reclaimed by nature. Our plastic waste, while persistent, would eventually break down under ultraviolet radiation and biological processes. Our metal structures would rust and corrode away. Even our nuclear facilities, built to last, would ultimately succumb to geological processes. What might survive? Perhaps some of our deep mines, filled with refined metals in concentrations never found naturally. Maybe layers of sediment contaminated with isotopes from our nuclear age. Possibly fossilized remains of our domestic animals, selectively bred into forms that never existed in nature. But would these subtle traces be enough for a future civilization to recognize that an advanced technological society once flourished here? The answer isn't as clear-cut as we might hope, and this uncertainty opens the door to some fascinating possibilities. Let's start with what we actually know about ancient civilizations on Earth. The oldest undisputed evidence of human civilization dates back roughly 12,000 years, to the end of the last ice age. But even within this relatively recent time frame, we continue to make discoveries that push back the boundaries of what we thought possible for our ancestors. Take Göbekli Tepe in modern-day Turkey. This archaeological site, with its massive stone pillars arranged in complex circular patterns, was constructed over 11,000 years ago. That makes it older than Stonehenge by about 6,000 years, older than the pyramids of Egypt by roughly 7,000 years. What makes Göbekli Tepe so remarkable isn't just its age, but its sophistication. The site required coordinated effort from hundreds of people, advanced knowledge of engineering and astronomy, and a level of social organization that archaeologists previously thought impossible for hunter-gatherer societies. But Göbekli Tepe is just one example of how our understanding of the past continues to evolve. In recent decades, we've discovered evidence of sophisticated astronomy among the Antikythera mechanism builders of ancient Greece, advanced metallurgy among Bronze Age civilizations, and complex mathematical knowledge among the Maya that rivaled our own understanding in some areas. Each discovery forces us to reconsider our assumptions about the capabilities of ancient peoples, and if we're consistently underestimating the sophistication of civilizations we know existed, how many others might we be missing entirely? The ocean covers more than 70% of our planet's surface, yet we've explored less than 5% of it. Vast underwater plains, deep trenches, and submerged continental shelves remain largely unmapped and unexplored. During the last ice age, which ended only about 11,000 years ago, sea levels were approximately 400 feet lower than they are today. Enormous areas that are now underwater were once dry land, potentially suitable for human habitation. If advanced civilizations existed during those times, their remains would now lie beneath hundreds of feet of water, covered by thousands of years of sediment. Only recently have underwater archaeologists begun to explore these submerged landscapes, and their discoveries have been remarkable. Off the coast of India, sonar has revealed what appear to be geometric structures buried beneath the seafloor. Near Japan, the Yonaguni Monument presents formations that some researchers argue are too geometric to be entirely natural. These underwater discoveries don't prove the existence of lost civilizations, but they remind us how much of our planet's surface remains unexplored. They highlight the gaps in our knowledge and the possibility that entire chapters of human history might be hidden beneath the waves. But let's think even bigger. What if we expand our definition of advanced civilization beyond human societies? What if intelligence has arisen before on Earth, but not among our own species? This brings us to one of the most intriguing hypotheses in recent years, proposed by researchers Adam Frank and Gavin Schmidt. They call it the Silurian Hypothesis, named after a fictional reptilian species from the British science fiction series Doctor Who. The hypothesis asks, if an industrial civilization had existed on Earth millions of years before humans evolved, would we be able to detect it today? The answer is surprisingly complex. As we discussed earlier, direct physical evidence of such a civilization would be extremely difficult to preserve over geological timescales, but there might be other signatures we could look for. Industrial activity leaves chemical fingerprints in the geological record. The burning of fossil fuels, for instance, changes the ratio of carbon isotopes in the atmosphere, and these changes get locked into sediments and ice cores. Our current civilization is producing exactly these kinds of signatures. Future geologists studying rock layers from our era will find unusual concentrations of metals, synthetic chemicals that don't occur naturally, and isotopic ratios that clearly indicate massive industrial activity. They'll also find a sharp decline in biodiversity that some scientists are already calling the sixth mass extinction. Could similar signatures exist from earlier periods in Earth's history? The researchers who proposed the Silurian hypothesis point to several intriguing anomalies in the geological record. There are periods of rapid climate change that seem difficult to explain through natural processes alone. There are unusual isotopic signatures in certain rock layers. There are traces of refined metals in concentrations that don't quite fit with what we'd expect from natural processes. None of these anomalies definitively prove the existence of pre-human industrial civilizations. They could all have natural explanations, but they remind us that the history of our planet is far more complex and mysterious than we often assume. Let's consider another possibility entirely. What if advanced civilizations have existed, but they took forms so different from our own that we don't recognize their signatures? Human civilization is built around cities, agriculture, and increasingly complex technology. We've assumed that any advanced society would follow a similar trajectory, but intelligence might develop along entirely different pathways. Consider the octopus. These remarkable creatures possess intelligence that rivals many vertebrates. They use tools, solve complex problems, and demonstrate what appears to be curiosity and playfulness. Some species can change not just their color, but their skin texture to perfectly mimic their surroundings. They can navigate mazes, open jars, and even appear to play games. Yet octopuses are almost entirely solitary creatures with very short lifespans, usually living only 1 to 2 years. They don't build permanent structures or develop cumulative knowledge in the way human societies do. But what if octopuses had evolved differently? What if some ancient cephalopod species had developed longer lifespans and more social behavior? Could they have built underwater civilizations that left no trace we would recognize? Their cities might have been grown rather than built, using biological processes we can barely imagine. Their technology might have been entirely organic, indistinguishable from natural ecosystems after millions of years. This kind of thinking pushes us to question our assumptions about what civilization might look like. We tend to imagine advanced societies in terms of our own development, metal and stone structures, electronic devices, industrial processes, but intelligence might express itself in ways we haven't even considered. The same principle applies when we think about possible extraterrestrial civilizations. For decades, the search for extraterrestrial intelligence has focused primarily on detecting radio signals from space. The assumption has been that advanced civilizations would use radio communication just as we do. But this approach might be like looking for smoke signals in an age of fiber optic cables. Advanced civilizations might communicate through means we haven't discovered yet. They might have moved beyond radio waves entirely, using quantum entanglement, gravitational waves, or methods we can't even imagine. They might be all around us, communicating constantly, but using channels we don't know how to tune into. This brings us to one of the most famous questions in all of science, the Fermi paradox. Named after physicist Enrico Fermi, it can be stated simply: if the universe is so vast and has existed for so long, and if the conditions that led to life on Earth are reasonably common, then where is everybody? Why haven't we detected clear evidence of extraterrestrial intelligence? Various solutions have been proposed to this paradox. Maybe life is much rarer than we think. Maybe intelligence is common, but advanced technological civilizations tend to destroy themselves quickly. Maybe advanced civilizations deliberately hide their presence from younger species like ourselves. Or maybe they're so advanced that their activities are as invisible to us as our Wi-Fi signals are to ants. But here's another possibility that relates directly to our question tonight. Maybe we haven't detected extraterrestrial civilizations because we don't even recognize the signs of advanced civilization here on Earth. Maybe the universe is teeming with intelligence, but it takes forms so different from our expectations that we look right past it. This idea becomes even more intriguing when we consider the possibility of non-biological intelligence. What if consciousness and intelligence aren't limited to biological systems? What if they can emerge from any sufficiently complex information processing system? Recent advances in artificial intelligence have shown us that sophisticated behavior can emerge from non-biological systems, but these are still early examples created by human intelligence. What if natural processes could give rise to non-biological intelligence independently? Consider the Earth's magnetic field. It's generated by complex interactions between molten iron in our planet's core and our rotation. These interactions create patterns and fluctuations that we're only beginning to understand. The magnetic field extends far into space, interacting with solar wind and cosmic radiation in ways that affect everything from our weather to the behavior of migrating animals. Could such a system, operating over geological timescales, develop something analogous to intelligence? Could the planet itself, through processes we don't yet comprehend, have developed a form of awareness? This might sound like science fiction, but it's worth remembering that our own consciousness emerges from the complex interactions of billions of neurons, none of which are individually conscious. If awareness can emerge from biological complexity, why not from other kinds of complexity? Indigenous cultures around the world have long held beliefs that the Earth itself is alive and aware. Modern science has generally dismissed these ideas as primitive superstitions, but as we learn more about the interconnected systems that regulate our planet's climate, chemistry, and biology, some scientists are beginning to wonder if these ancient perspectives might contain insights we've overlooked. The Gaia hypothesis, proposed by scientist James Lovelock, suggests that Earth's living and non-living systems work together as a self-regulating entity. While Lovelock didn't claim that Earth is literally conscious, his idea points toward a level of planetary integration that we're only beginning to appreciate. What if this integration has been developing for billions of years? What if the Earth as a whole system has evolved forms of information processing and response that we don't recognize as intelligence, simply because they operate on scales of time and space so different from our own? These are speculative ideas, certainly, but they remind us how much we still don't understand about the nature of intelligence and consciousness. They suggest that when we ask whether we're the first advanced civilization on Earth, we might be asking the wrong question entirely. Let's shift our perspective and consider the evidence from a different angle. Instead of looking for traces of past civilizations, what if we look at the anomalies in our own development? What if some of the mysteries of human history actually point toward contact with earlier advanced civilizations? Human development shows some puzzling features that have long intrigued researchers. Our species, Homo sapiens, appears to have emerged relatively suddenly in evolutionary terms. Our brains are disproportionately large for our body size, and they consume an enormous amount of energy, about 20% of our total caloric intake. From a purely evolutionary standpoint, this seems inefficient unless there were very strong selective pressures favoring intelligence. But what were those pressures? Traditional explanations focus on tool use, social cooperation, and environmental challenges. These factors certainly played a role, but some researchers wonder if they fully explain the rapid development of human intelligence. Our species also shows some unusual characteristics compared to other primates. We're remarkably similar genetically, suggesting that all modern humans descended from a relatively small population that lived in Africa within the last 200,000 years. We lack the thick hair covering that protects most mammals. We have an unusual diving reflex, more pronounced than in other land mammals. We can consciously control our breathing in ways that most animals cannot. Some of these features have led to speculative theories about human origins. The aquatic ape hypothesis suggests that our ancestors went through a semi-aquatic phase, which would explain our streamlined bodies, reduced hair, and diving abilities. While this idea remains controversial among mainstream anthropologists, it highlights how much we still don't understand about our own evolutionary history. Could some of these unusual features result from contact with an earlier civilization? It's a provocative idea, though one that lacks concrete evidence. But it reminds us that human development itself contains mysteries we haven't fully solved. The same can be said for the sudden emergence of human civilization after the last ice age. For hundreds of thousands of years, our species lived as hunter-gatherers, with relatively simple tools and social structures. Then, in a remarkably short period of time, we developed agriculture, cities, writing, mathematics, and complex technologies. This transition happened independently in multiple locations around the world, from Mesopotamia to the Indus Valley to China to Mesoamerica. The speed and similarity of these developments have puzzled historians and archaeologists. Why did civilization emerge so suddenly, and why in so many places at once? Traditional explanations focus on climate change at the end of the Ice Age, population growth, and the development of agriculture. These factors were certainly important, but some researchers wonder if there might have been additional influences we haven't considered. ancient texts from around the world contain remarkably similar stories of teachers or civilizers who appeared at crucial moments in human development. These figures, whether called Oannes in Mesopotamia, Quetzalcoatls in Mesoamerica, or Viracocha in Peru, are described as bringing knowledge of agriculture, astronomy, mathematics, and social organization to human societies. Most scholars interpret these stories as mythological, symbolic representations of cultural development. But what if they contain memories of actual contact with a more advanced civilization? What if the rapid development of human society after the Ice Age was influenced by knowledge passed down from an earlier period? This idea ventures into controversial territory, and it's important to approach it with appropriate skepticism. Extraordinary claims require extraordinary evidence, and we don't have definitive proof of contact with earlier civilizations. But the stories themselves are intriguing, and they remind us that oral traditions often preserve historical information that we might otherwise lose. Consider the Aboriginal Australian tradition of the Dreamtime, which includes detailed descriptions of geographical features and events that occurred tens of thousands of years ago. Modern geological and archaeological research has confirmed the accuracy of many of these oral histories, suggesting that human societies can preserve information over much longer periods than previously thought. If human oral traditions can accurately preserve information for tens of thousands of years, might they also preserve memories of contact with other advanced civilizations? It's a possibility worth considering, even if we can't prove it definitively. Let's explore another angle. What about the technological knowledge that appears in ancient texts? Throughout history, there are descriptions of devices and processes that seem advanced for their time, sometimes impossibly so. The ancient Indian texts, known as the Vedas, some of which may date back over 3,000 years, contain descriptions of flying vehicles called vimanas. These texts provide detailed accounts of aerial warfare, navigation systems, and propulsion methods that sound remarkably similar to modern aircraft technology. Traditional scholars interpret these as poetic or mythological descriptions, but some researchers wonder if they might represent memories of actual technologies. Similarly, ancient Chinese texts describe devices that could generate light without fire, weapons that could strike targets at great distances, and methods for communicating across vast spaces instantly. The ancient Greeks wrote about automatons, self-moving statues that could perform complex tasks. Again, mainstream scholarship generally views these as imaginative literature rather than historical records. But they raise intriguing questions about the sources of such detailed technical descriptions in societies that supposedly lacked advanced technology. The same pattern appears in architectural achievements that push the boundaries of what we thought ancient civilizations could accomplish. The precision of the Egyptian pyramids, the massive stone blocks of Pumapunku in Bolivia, the complex engineering of Roman concrete that remains durable after 2,000 years, all of these achievements suggest knowledge and capabilities that we're still working to fully understand. Modern attempts to replicate some of these ancient achievements using the tools and methods supposedly available at the time have proven surprisingly difficult. This doesn't necessarily mean that ancient peoples had access to advanced technology, but it does suggest that they possessed knowledge and skills that we may have underestimated or lost entirely. The question of lost knowledge becomes even more intriguing when we consider how much scientific and technical information has been lost throughout history. The Library of Alexandria, which supposedly contained much of the ancient world's accumulated knowledge, was destroyed. The Maya codices, which contained detailed astronomical and mathematical information, were mostly burned by Spanish conquistadors. Viking exploration records that might have documented extensive travel and discovery were lost to time and conflict. If so much knowledge has been lost from relatively recent periods, how much more might have been lost from earlier eras? Could there have been scientific and technical traditions that developed over thousands of years, only to be wiped out by natural disasters, warfare, or cultural collapse? The possibility becomes more plausible when we consider how fragile our own information storage systems really are. Most of our current knowledge exists in digital form, stored on devices that require constant maintenance and regular updating. If our technological civilization were to collapse tomorrow, how much of our accumulated knowledge would survive? Physical books printed on acid-free paper might last a few hundred years. Stone tablets might survive longer, but they can only hold limited information. In contrast, knowledge preserved in human memory and oral tradition, while less precise, can potentially survive for thousands of years. This suggests that earlier civilizations might have relied more heavily on oral traditions and might have preserved knowledge in ways we don't fully appreciate. Let's consider another possibility. What if advanced ancient civilizations existed, but they chose to limit their impact on the environment? What if they developed technologies that were inherently sustainable and left minimal traces in the geological record? Our current industrial civilization is based on extracting and burning fossil fuels, mining metals from the earth, and producing massive amounts of waste. This approach has allowed rapid technological development, but it's also created environmental problems that threaten our long-term survival. It's not necessarily the only path to advanced technology. Imagine a civilization that developed advanced understanding of biology and ecology. Instead of mining metals, they might have grown materials with the properties they needed. Instead of burning fossil fuels, they might have harnessed biological processes or renewable energy sources. Instead of producing waste, they might have designed closed-loop systems where every output became input for another process. Such a civilization might have achieved remarkable technological capabilities while leaving little trace in the archaeological record. Their cities might have been grown rather than built, designed to integrate seamlessly with natural ecosystems. Their vehicles might have been biological, living creatures bred or engineered for transportation. Their information storage might have been genetic, encoded in the DNA of specially designed organisms. This isn't pure fantasy. Modern biotechnology is already exploring many of these possibilities. We're learning to grow materials with specific properties, to engineer organisms that produce useful chemicals, and to store information in DNA. An ancient civilization with thousands of years to develop these approaches might have achieved levels of integration with nature that we can barely imagine. From our perspective, such a civilization might be almost invisible. Their remains would be indistinguishable from natural ecosystems. Their technologies would have biodegraded long ago. Only their genetic modifications might survive, and even those would be difficult to recognize as artificial after millions of years of natural evolution. This idea connects to broader questions about the relationship between intelligence and sustainability. Our current civilization faces serious environmental challenges because of our impact on Earth's systems. Climate change, biodiversity loss, pollution, and resource depletion all threaten our long-term survival. If we don't find solutions to these problems, our advanced technological civilization might not last very long in geological terms. Could this be a pattern that repeats throughout history? Could civilizations regularly rise to advanced levels only to collapse because they can't solve the sustainability challenge? And could the civilizations that do survive be the ones that learn to minimize their environmental impact, making them nearly invisible to future archaeologists? This brings us back to the Fermi paradox and the question of why we don't see obvious signs of extraterrestrial civilizations. Maybe the civilizations that survive long enough to become truly advanced are also the ones that learn to hide their presence, either intentionally or as a natural consequence of sustainable technology. From this perspective, the absence of obvious alien megastructures or radio signals might not mean that advanced civilizations are rare. It might mean that the advanced civilizations are the quiet ones, the ones that have learned to work with natural systems rather than against them. But let's bring our focus back to Earth and consider some of the more concrete evidence for possible ancient advanced civilizations. While we can't prove their existence definitively, there are some intriguing anomalies that deserve careful consideration. One area of particular interest is precision stonework found at ancient sites around the world. The blocks at Puma Punku in Bolivia, for example, are cut with such precision that they fit together without mortar, and the surfaces are so smooth and flat that they meet modern architectural standards. The angles are exact, and some of the blocks show evidence of machine-like precision in their construction. Similar precision stonework appears at sites in Peru, Egypt, Lebanon, and other locations. In many cases, these precisely cut stones are incorporated into structures that also show evidence of more primitive construction techniques, suggesting that different building phases use different technologies or knowledge bases. The tools and methods used to achieve this precision remain unclear. Traditional archaeology suggests that these effects could be achieved with bronze tools, wooden wedges, and careful craftsmanship. But experimental attempts to replicate the results using these methods have had mixed success, and some researchers argue that the precision observed would require more advanced techniques. Another area of interest is ancient knowledge of astronomy and mathematics. Many ancient civilizations demonstrated sophisticated understanding of celestial mechanics, often incorporating this knowledge into their architecture and calendars. The Maya, for example, calculated the length of the solar year to 365.2420 days, remarkably close to the modern measurement of 365.2422 days. They tracked the cycles of Venus with extraordinary precision and predicted eclipses hundreds of years in advance. Their mathematical system included the concept of zero, which didn't appear in European mathematics until much later. The builders of Stonehenge aligned their monument to track solstices, equinoxes, and lunar cycles with impressive accuracy. The Antikythera mechanism, a Greek device from around the 1st century BCE, was a sophisticated mechanical computer capable of predicting the positions of planets and the timing of eclipses. These achievements suggest that ancient peoples possessed mathematical and astronomical knowledge that we've only recently rediscovered or exceeded. While this knowledge could have been developed through careful observation over many generations, some researchers wonder if it might indicate contact with even more advanced sources of information. The global distribution of similar mythological themes also raises interesting questions. The flood myths appear in cultures around the world, often with remarkably similar details. Stories of flying beings, underwater cities, and catastrophic events that reshape civilization appear independently in many different traditions. Joseph Campbell and other scholars have argued that these similarities reflect universal human psychological patterns, archetypes that appear naturally in all cultures, but others wonder if they might represent shared historical memories, perhaps preserved from a time when human populations were more connected, or when they experienced common influences. The flood myths are particularly intriguing because they often describe events that would have occurred at the end of the last ice age, when massive amounts of water were released from melting ice sheets. These events would have caused dramatic changes in sea level and could have destroyed coastal civilizations around the world. If advanced civilizations existed during the Ice Age, their remains would now be underwater, buried under hundreds of feet of sediment. The flood myths found in cultures around the world might preserve memories of these catastrophic events and the civilizations they destroyed. Recent underwater archaeological discoveries have begun to reveal submerged structures that might support this interpretation. Off the coast of Japan, the Yonaguni monument appears to show geometric patterns that some researchers argue are too regular to be entirely natural. Similar structures have been reported near India, Cuba, and other locations. These discoveries are still controversial, and many mainstream archaeologists argue that the structures can be explained through natural geological processes, but they remind us how much of our planet's history remains unexplored beneath the oceans. The ocean covers more than 70% of Earth's surface, yet we've mapped it less thoroughly than we've mapped the Moon or Mars. The deep ocean basins, in particular, remain largely unexplored. If ancient civilizations developed advanced underwater technologies, their remains might still be waiting for discovery on the abyssal plains. This possibility becomes more intriguing when we consider that water covers not just our ocean floors, but also many areas that were dry land during previous ice ages. The continental shelves, now submerged under hundreds of feet of water, were exposed during periods of lower sea level. These areas would have been prime locations for ancient settlements, with access to both marine and terrestrial resources. During the last glacial maximum, about 20,000 years ago, sea levels were approximately 400 feet lower than they are today. Vast areas that are now underwater were then habitable land, including regions off the coasts of all continents. If civilizations developed in these areas, their remains would now be deeply submerged and buried under millennia of sediment. The English Channel, for example, was dry land during much of the Ice Age, connecting Britain to continental Europe. The North Sea was mostly dry land, with rivers flowing through valleys that are now underwater. Similar land bridges and coastal plains existed around the world, potentially supporting human populations for thousands of years. Some of these submerged landscapes are now being explored using advanced sonar and underwater robotics. The results have been fascinating, revealing ancient river systems, forests, and even what appear to be human artifacts. But the exploration is still in its early stages, and much remains to be discovered. The challenge of underwater archaeology is immense. Not only are these sites difficult to access, but they've been subjected to thousands of years of sedimentation, current action, and biological activity. Organic materials have long since decayed, and even stone structures can be broken apart by wave action and covered by marine growth. Yet despite these challenges, underwater archaeologists continue to make remarkable discoveries. Ancient shipwrecks provide insights into past technologies and trade networks. Submerged caves preserve evidence of early human occupation, and occasionally, structures are found that challenge our understanding of ancient capabilities. The exploration of these underwater frontiers is just beginning, but it's already clear that the submerged landscapes hold important clues about human history and the possibility of earlier civilizations. As technology improves and exploration becomes more systematic, we may discover evidence that fundamentally changes our understanding of the past. Let's shift our focus from the archaeological evidence to consider the theoretical frameworks that might help us understand the possibility of earlier advanced civilizations. One approach is to think about the conditions necessary for technological civilization to develop, and how often these conditions might have occurred throughout Earth's history. The development of human civilization required several key factors. First, we needed a stable climate that allowed agriculture to develop. Second, we needed sufficient population density to support specialization and innovation. Third, we needed access to energy sources and raw materials that could fuel technological development. Fourth, we needed social and cultural systems that could preserve and transmit knowledge across generations. How often might these conditions have been met throughout Earth's history? Our planet has experienced numerous periods of climate stability, each lasting millions of years. During these periods, ecosystems had time to develop complexity and diversity. If intelligence evolved during any of these periods, it would have had ample time to develop sophisticated civilizations. The availability of energy and raw materials has also varied throughout Earth's history. Different geological periods have been characterized by different distributions of minerals, fossil fuels, and other resources. Some periods might have been more favorable for technological development than others. The social and cultural conditions necessary for civilization are harder to assess from the geological record, but we know that many species have developed complex social behaviors, communication systems, and even tool use. If any of these species had evolved larger brains and longer lifespans, they might have been capable of developing cumulative cultural traditions. The question becomes, how likely is it that all these conditions would have aligned to produce advanced civilizations at some point during Earth's 4.5 billion year history? Given the vast spans of time involved, it seems quite possible that the right conditions might have occurred multiple times. But even if advanced civilizations did develop, would they necessarily leave traces we could recognize? As we've discussed, the preservation of evidence over geological timescales is extremely challenging. Most of what exists on Earth's surface is eventually recycled through geological processes like erosion, sedimentation, and plate tectonics. The portions of Earth's surface that we can study represent only a tiny fraction of the planet's history. Most of the rock record has been destroyed and recycled. The ocean floors, which cover most of the planet, are continuously renewed through seafloor spreading, with the oldest oceanic crust being only about 200 million years old. This means that even if advanced civilizations existed hundreds of millions of years ago, most direct evidence of their existence would have been destroyed by natural processes. Only traces preserved in very specific geological environments would survive to the present day. The search for such traces is complicated by the fact that we don't know exactly what to look for. Our own industrial civilization is creating distinctive signatures in the geological record, but an earlier civilization might have developed along entirely different pathways, leaving different kinds of evidence. For example, our civilization is characterized by the extensive use of fossil fuels, which creates distinctive isotopic signatures in the atmosphere and oceans, but an earlier civilization might have relied primarily on renewable energy sources, leaving no such signature. Our civilization produces large quantities of synthetic materials like plastics, but an earlier civilization might have used primarily biological or mineral materials that would be indistinguishable from natural products after millions of years. The more we think about the challenges of preserving evidence over geological timescales, the more we realize how difficult it would be to definitively prove or disprove the existence of earlier advanced civilizations. This uncertainty leaves room for speculation and wonder, but it also highlights the importance of keeping an open mind as we continue to explore our planet's history. Recent advances in technology are opening new avenues for investigation. Sophisticated instruments can detect minute traces of human impact in ice cores, sediment layers, and rock formations. Satellite imagery can reveal subtle patterns on Earth's surface that might indicate ancient structures. Deep ocean exploration is becoming more feasible with improved robotics and submersibles. These technological advances might eventually provide the tools necessary to detect evidence of earlier civilizations, if such evidence exists. But they also remind us how much we still don't know about our own planet. Despite centuries of scientific exploration, Earth continues to surprise us with new discoveries and unexpected phenomena. This brings us to one of the most important aspects of the question we're exploring tonight. Regardless of whether earlier advanced civilizations actually existed on Earth, the very act of asking the question changes how we think about ourselves and our place in the cosmic story. For most of human history, people believed that their particular culture or civilization was the center of the universe, the pinnacle of creation, the ultimate purpose toward which all of history had been building. This kind of thinking is natural and probably inevitable, but it can also be limiting. When we seriously consider the possibility that we might not be the first advanced civilization on Earth, we're forced to adopt a more humble perspective. We begin to see ourselves as part of a larger pattern, one link in a chain that might extend both backward and forward in time far beyond what we can currently perceive. This perspective can be both humbling and inspiring. Humbling, because it suggests that we might not be as unique or central as we like to think. Inspiring, because it opens up vast possibilities for what intelligence might achieve over cosmic timescales. If advanced civilizations have risen and fallen before us, what can we learn from their possible trajectories? What challenges did they face? How did they adapt to changing conditions? What caused their eventual decline or transformation? Even without definitive answers to these questions, thinking about them can help us better understand our own situation. We're currently facing challenges that could determine the long-term survival of our civilization: climate change, environmental degradation, resource depletion, social inequality, and the risk of conflict or technological disaster. How we handle these challenges will determine whether our civilization thrives for thousands of years or collapses within the next few centuries. If we can learn to live sustainably on our planet, to manage our technologies wisely, and to cooperate effectively as a global society, we might join the ranks of civilizations that endure over geological timescales. But if earlier civilizations did exist and then disappeared, their fate serves as a reminder that no civilization is guaranteed survival. Intelligence and technology are powerful tools, but they're not automatically beneficial. They can be used to solve problems or to create new ones. They can help societies adapt to challenges or accelerate their own destruction. The question of whether we're the first advanced civilization on Earth thus becomes more than just a matter of historical curiosity. It becomes a lens through which we can examine our own trajectory and consider what we want to achieve as a species. From this broader perspective, the search for evidence of earlier civilizations is really a search for understanding about the nature and potential of intelligence itself. What can intelligence accomplish given enough time and resources? What are the common challenges that all advanced societies must face? What strategies lead to long-term survival and flourishing? These questions become even more fascinating when we consider the possibility that intelligence might not be limited to biological systems at all. Throughout our discussion tonight, we've mostly focused on civilizations built by living creatures like ourselves. But what if consciousness and intelligence can emerge from other kinds of complex systems? The Earth itself is an incredibly complex system, with intricate feedback loops connecting the atmosphere, oceans, geology, and biosphere. Over billions of years, these systems have evolved together, creating what some scientists call the Gaia system, a planetary-scale network of interactions that maintains conditions suitable for life. Could such a system develop something analogous to awareness or intelligence? The idea might sound far-fetched, but consider how our own consciousness emerges from the complex interactions of billions of neurons, none of which are individually conscious. If awareness can emerge from biological complexity, perhaps it could also emerge from other kinds of complexity operating on different scales of space and time. The Earth's magnetic field provides an intriguing example. Generated by the motion of molten iron in our planet's core, this field extends far into space and interacts with solar radiation in ways that affect everything from our climate to animal migration patterns. The magnetic field has reversed many times throughout Earth's history, sometimes in regular patterns, and sometimes apparently randomly. These reversals involve massive reorganizations of energy and information on a planetary scale. The processes involved are so complex that we still don't fully understand them, despite decades of study. Could such processes, operating over millions of years, develop information processing capabilities that we don't recognize as intelligence, simply because they operate on such different timescales? Indigenous traditions around the world have long maintained that the Earth itself is alive and conscious. Modern science has generally dismissed these ideas, but perhaps we've been too quick to reject possibilities that don't fit our current paradigms. As we learn more about complex systems, emergence, and information processing, the boundary between living and non-living systems becomes increasingly blurred. Consider the global climate system. It processes vast amounts of information about solar radiation, atmospheric composition, ocean currents, and land surface conditions. It responds to changes in these inputs with complex feedback mechanisms that maintain relatively stable conditions over long periods. When viewed from this perspective, the climate system exhibits behaviors that look remarkably similar to homeostasis in living organisms. The Internet provides another example of a complex system that might be developing emergent properties we don't fully understand. Billions of computers connected through global networks, processing and sharing information at unprecedented scales and speeds. The patterns of information flow through these networks are becoming increasingly complex, with artificial intelligence systems beginning to exhibit behaviors that we didn't explicitly program. Some researchers speculate that the Internet might eventually develop emergent properties analogous to consciousness. While this remains highly speculative, it illustrates how complex information processing systems might give rise to unexpected phenomena. If we're willing to consider these possibilities for systems we're creating, why not for systems that have been developing naturally for billions of years? The Earth has had vast amounts of time to develop complex information processing capabilities through natural selection and system evolution. From this perspective, the question of whether we're the first advanced civilization on Earth takes on new dimensions. Maybe the first advanced civilization on our planet wasn't built by any particular species. Maybe it was the planet itself, developing planetary-scale intelligence over geological timescales. Such intelligence might express itself in ways we haven't learned to recognize. It might communicate through subtle changes in climate patterns, magnetic field fluctuations, or seismic activity. It might influence the evolution of life in ways that seem like natural selection, that actually represent conscious guidance of planetary development. This isn't to suggest that every natural phenomenon represents conscious intelligence, but it does suggest that we might be too limited in our thinking about what intelligence and consciousness might look like when they emerge from systems very different from our own brains. The search for extraterrestrial intelligence faces similar challenges. We've been listening for radio signals from space for decades, based on the assumption that advanced civilizations would use radio communication, but this approach reflects our own technological development rather than any fundamental principle about how intelligence must communicate. Advanced extraterrestrial civilizations might communicate through gravitational waves, quantum entanglement, or methods we haven't discovered yet. They might have moved beyond electromagnetic radiation entirely. They might be communicating constantly, all around us, but using channels we don't know how to detect. This possibility becomes even more intriguing when we consider that intelligence might be far more common in the universe than we've assumed. If consciousness can emerge from many different kinds of complex systems, then the universe might be teeming with forms of intelligence that we simply don't recognize. Stars themselves are incredibly complex systems, with intricate magnetic fields, nuclear processes, and plasma dynamics that we're only beginning to understand. Galaxies are even more complex, with billions of stars interacting through gravitational and electromagnetic forces over vast scales of space and time. Could such systems develop emergent properties analogous to intelligence? The idea pushes the boundaries of what we consider possible, but it's worth remembering that many phenomena we now accept as scientific fact once seemed impossible to previous generations. The discovery of quantum mechanics revealed that reality operates according to principles that seem to violate common sense. The realization that space and time are relative rather than absolute fundamentally changed our understanding of the universe. The recognition that living systems can emerge from non-living matter challenged our assumptions about the nature of life itself. Perhaps we're on the verge of another such paradigm shift, one that will expand our understanding of intelligence and consciousness beyond the narrow boundaries of biological brains. If so, the question of whether we're the first advanced civilization on Earth might be just the beginning of a much larger exploration of intelligence throughout the cosmos. But let's return to more concrete considerations and explore some of the specific mysteries that might relate to earlier advanced civilizations on our own planet. One area that has long fascinated researchers is the remarkable similarity of certain technologies and knowledge systems that appeared independently in different parts of the world. The development of agriculture, for example, occurred roughly simultaneously in multiple locations around the globe at the end of the last ice age. In Mesopotamia, China, Mesoamerica, and the Andes, people began domesticating plants and animals and developing farming techniques within a few thousand years of each other. This timing might be explained by climate changes that made agriculture more feasible worldwide, but the specific techniques that developed show some striking similarities despite the geographical isolation of these regions. Terraced farming, irrigation systems, crop rotation, and selective breeding all appeared independently in multiple locations. Similar patterns appear in other areas of human development. Pyramid construction occurred in Egypt, Mesoamerica, and other locations with no apparent contact between the builders. Complex astronomical observations and mathematical calculations developed independently in multiple civilizations. Metallurgy, writing systems, and urban planning all show similar independent development in different parts of the world. Traditional explanations for these similarities focus on the concept of convergent evolution. Just as biological species facing similar environmental challenges often evolve similar solutions, human societies facing similar problems might independently develop similar technologies and social systems. This explanation is probably correct for most cases, but some researchers wonder if there might be additional factors involved. Could some of these similarities result from contact with knowledge sources that predate the civilizations we know about? The idea becomes more plausible when we consider how much human migration and contact occurred during the Ice Age. Recent genetic and archaeological evidence suggests that human populations were more mobile and interconnected than previously thought. People traveled vast distances across land bridges and along coastlines, spreading technologies and knowledge as they went. If advanced civilizations existed during or before the Ice Age, their knowledge might have been preserved and transmitted through these migration networks. The similarities we see in post-Ice Age civilizations might reflect shared inheritance from earlier sources rather than truly independent development. This possibility is supported by the oral traditions of many indigenous cultures, which often include detailed knowledge about events that occurred thousands of years before the cultures themselves were established. The ability of oral traditions to preserve accurate information over vast timescales suggests that knowledge from much earlier periods might have survived to influence later developments. The Aboriginal Australian traditions provide particularly striking examples. Their oral histories include accurate descriptions of geographical features and events that occurred over 40,000 years ago. If human cultures can preserve such detailed information for so long, they might also preserve technical knowledge from earlier civilizations. Similar long-term preservation of knowledge appears in other cultures around the world. The Vedic traditions of India include detailed astronomical observations that seem to date back thousands of years. The Mayan codices contained mathematical and astronomical knowledge that took European scholars centuries to rediscover. Many indigenous cultures possess sophisticated understanding of ecology, medicine, and navigation that reflects centuries or millennia of accumulated observation and experimentation. Could some of this traditional knowledge represent inheritance from even earlier advanced civilizations? It's difficult to prove, but the possibility reminds us that human knowledge systems are far more complex and ancient than we often assume. The question becomes even more interesting when we consider the role of catastrophic events in human history. Our planet has experienced numerous disasters that could have destroyed entire civilizations, while leaving only fragmentary knowledge for survivors to pass on to future generations. The Younger Dryas period, which occurred roughly 12,000 years ago, provides a particularly intriguing example. This event involved rapid climate change that ended the last ice age, causing massive flooding, species extinctions, and environmental disruption worldwide. The scale of these changes would have been devastating for any civilizations that existed at the time. Recent research has suggested that the Younger Dryas might have been triggered by impacts from asteroids or comets, possibly multiple impacts over a period of centuries. Such impacts would have caused massive fires, atmospheric disturbances, and climate changes that could have ended entire civilizations almost overnight. If advanced civilizations existed before the Younger Dryas, most traces of their existence would have been destroyed by the catastrophic events of that period. Only scattered survivors with fragmentary knowledge would have remained to rebuild civilization in the aftermath. This scenario might explain some of the puzzling features of early post-Ice Age civilizations: the rapid development of complex technologies, the similarities between distant cultures, and the advanced knowledge embedded in ancient traditions might all reflect inheritance from pre-catastrophe civilizations. The flood myths found in cultures around the world might preserve memories of the catastrophic events that ended these earlier civilizations. The stories of teachers and civilizers who appeared after the disasters might describe survivors who retained knowledge from the earlier period and used it to help establish new societies. While this remains speculative, it provides a framework for understanding some of the mysteries of ancient history. It also highlights the fragility of civilization and the importance of preserving knowledge through multiple channels and storage systems. Our own civilization faces similar vulnerabilities: climate change, asteroid impacts, volcanic eruptions, or other catastrophic events could destroy much of our technological infrastructure and force survivors to rebuild from scattered remnants. How much of our current knowledge would survive such a collapse? How would future archaeologists interpret the fragmentary remains of our cities and technologies? These questions bring us back to the broader implications of asking whether we're the first advanced civilization on Earth. Regardless of the answer, the question forces us to think about the long-term trajectory of intelligence and technology on our planet. If we are indeed the first advanced civilization, then we bear a special responsibility for the future development of intelligence on Earth. Our choices will determine whether technological civilization continues to develop or whether it ends with us. We're writing the first chapter of a story that could continue for millions or billions of years. But if earlier advanced civilizations existed and then disappeared, their fate serves as both a warning and a source of hope. A warning because it demonstrates that no civilization is guaranteed survival, no matter how advanced it becomes, but also a source of hope because it suggests that intelligence and civilization can recover from even catastrophic setbacks. From this perspective, our current civilization might be just one episode in a much larger story of intelligence on Earth. We might be the latest attempt by the universe to understand itself through conscious awareness. If we succeed in creating a sustainable, long-lasting civilization, we continue the story. If we fail, future intelligences might eventually take up the task. This long-term view can be both humbling and inspiring. Humbling because it suggests that we might not be as unique or permanent as we like to think. Inspiring because it places our efforts in the context of a cosmic scale project that extends far beyond our individual lives or even our species. Whether or not earlier advanced civilizations existed on Earth, we're certainly part of a universe that has been experimenting with intelligence and consciousness for billions of years. The same physical processes that created stars and planets also created brains and minds. The same evolutionary forces that shaped the development of life also shaped the development of intelligence. In asking whether we're the first advanced civilization on Earth, we're really asking about our place in this vast cosmic experiment. Are we pioneers, exploring territory that no intelligence has explored before? Or are we following paths that others have traveled, learning lessons that others have already learned? The answer might be some combination of both. Even if earlier civilizations existed, each intelligence faces unique challenges and opportunities. Each civilization must find its own solutions to the problems of existence. Each must discover its own relationship with the natural world and its own purpose in the cosmic story. But civilizations might also share common patterns and face similar challenges. The laws of physics are the same throughout the universe. The dynamics of complex systems follow similar principles whether they're biological, technological, or planetary in scale. The challenges of sustainability, cooperation, and long-term thinking might be universal features of advanced intelligence. If so, then studying the possibility of earlier civilizations on Earth becomes more than just historical curiosity. It becomes a way of understanding the general principles that govern the development and survival of intelligence throughout the cosmos. This brings us to one of the most profound implications of our question tonight. If intelligence is a common feature of the universe, so if civilizations regularly rise and fall throughout cosmic history, then consciousness might be one of the fundamental ways that the universe explores its own possibilities. Through conscious awareness, the universe becomes able to observe itself, to understand its own laws and processes, to imagine alternative futures, and work toward preferred outcomes. In this sense, every conscious being is a temporary focus of cosmic self-awareness, a brief window through which the universe experiences itself subjectively. If this perspective is correct, then the question of whether we're the first advanced civilization on Earth takes on cosmic significance. Each civilization represents a unique experiment in consciousness, a different way for the universe to understand itself. Some experiments might last longer than others, some might achieve greater insights, but each contributes to the overall pattern of cosmic self-discovery. From this view, our civilization's current challenges, whether climate change, technological disruption, or social conflict, are not just local problems affecting one species on one planet. They're part of the universe's ongoing exploration of what consciousness can achieve when it reaches a certain level of complexity and capability. How we handle these challenges will determine not just our own fate, but also what the universe learns about the possibilities and limitations of intelligence. If we succeed in creating a sustainable, peaceful, and exploratory civilization, we demonstrate that intelligence can be a constructive force in cosmic evolution. If we fail, we provide data about the pitfalls and limitations that consciousness faces when it reaches our level of development. Either way, our efforts contribute to the universe's understanding of itself. But obviously, we'd prefer to contribute a success story, rather than a cautionary tale. This preference gives us motivation to work towards solutions to our current challenges and to think carefully about the long-term trajectory of our civilization. The search for evidence of earlier advanced civilizations on Earth thus becomes part of a larger project of understanding intelligence throughout the cosmos. Every piece of evidence we gather, every theory we develop, every question we ask contributes to our understanding of what consciousness can achieve given enough time and resources. Even if we never find definitive proof of earlier civilizations on our planet, the search itself is valuable. It expands our thinking about the possibilities of intelligence. It challenges our assumptions about the uniqueness of our own development. It provides frameworks for thinking about the long-term future of consciousness in the universe. And perhaps most importantly, it reminds us that we're part of something much larger than ourselves. Whether or not we're the first advanced civilization on Earth, we're certainly part of the universe's ongoing experiment with intelligence and consciousness. We're participants in a story that began billions of years ago and will continue long after our current civilization has ended. This perspective can provide both meaning and motivation for our current efforts. We're not just trying to solve problems for our own benefit, or even for the benefit of our species. We're contributing to the universe's understanding of what intelligence can accomplish. We're helping to write the next chapter in the story of consciousness in the cosmos. The question of whether we're the first advanced civilization on Earth might never be answered definitively. The evidence is fragmentary, the timescales are vast, and the challenges of preservation over geological time are immense. But the question itself is valuable because it opens our minds to possibilities we might not otherwise consider. It reminds us that intelligence might be far more common and diverse than we assume. It suggests that consciousness might emerge from many different kinds of complex systems, operating on many different scales of space and time. It challenges us to think beyond our own immediate experience and consider our place in the larger patterns of cosmic evolution. Whether we're the first or the latest in a long series of experiments with intelligence on Earth, we have the opportunity to learn from the successes and failures of the past and to contribute our own insights to the ongoing story of consciousness in the universe. The cosmos has been patient with its experiments in intelligence. It has provided billions of years for life to develop and diversify. It has created countless opportunities for consciousness to emerge and explore its own possibilities. Some of these experiments have lasted longer than others, some have achieved greater complexity, but each has contributed something unique to the overall pattern. Our own experiment with intelligence is still in its early stages. We've existed as a technological species for only a few centuries, barely a blink of an eye in cosmic terms. We don't yet know whether our particular approach to civilization will prove sustainable over the long term. We don't know what we might accomplish if we succeed in solving our current challenges and continue developing for thousands or millions of years. But we do know that we're part of something magnificent. We're conscious beings in a universe that has spent billions of years creating the conditions for consciousness to emerge. We're able to contemplate our own existence, to wonder about our origins and destiny, to imagine futures that don't yet exist and work toward making them real. Whether or not we're the first advanced civilization on Earth, we're certainly among the first conscious beings capable of asking such questions. We're among the first to develop technologies that could either destroy civilization or carry it to heights we can barely imagine. We're among the first to recognize our own cosmic context and consider our responsibilities as conscious participants in the universe's ongoing evolution. This recognition comes with both privilege and responsibility. The privilege of being aware, of being able to experience beauty and wonder, of being able to love and create and explore, but also the responsibility of using our consciousness wisely, of making choices that contribute positively to the cosmic experiment in intelligence. As we continue our exploration of whether we're the first advanced civilization on Earth, we're really exploring the nature and potential of consciousness itself. We're asking what intelligence can accomplish, what challenges it must face, what possibilities it might realize given enough time and wisdom. The answers to these questions will determine not just our own future, but also what the universe learns about itself through our consciousness. In asking whether we're the first, we're really asking what it means to be conscious participants in the cosmic story of intelligence and awareness. And that, perhaps, is the most important question of all. Not whether we're first or last, unique or common, but what we choose to do with the consciousness we've been given. How we choose to explore the possibilities of intelligence, what we choose to contribute to the universe's understanding of itself. The search for earlier civilizations on Earth is ultimately a search for wisdom about how to be conscious beings in a vast and ancient cosmos. Whether we find evidence of predecessors or not, we're still faced with the same fundamental challenges and opportunities that any conscious civilization must face. We must learn to live sustainably on our planet, to cooperate effectively as a global society, to use our technologies wisely, and to think beyond our immediate needs and desires. We must find ways to preserve and transmit knowledge across generations while remaining adaptable to changing conditions. We must balance exploration and innovation with wisdom and caution. These challenges are not unique to our civilization. They're likely universal features of advanced intelligence anywhere in the cosmos. How we handle them will determine not just our own fate, but also what the universe learns about the possibilities and limitations of consciousness. In this sense, every choice we make, as individuals and as a civilization, contributes to the cosmic experiment in intelligence. Every act of creativity, every moment of compassion, every effort to understand and improve our world adds to the universe's accumulating wisdom about what consciousness can achieve. Whether we're the first advanced civilization on Earth or the latest in a long series, we have the opportunity to make our contribution to this ongoing experiment as positive and constructive as possible. We can choose to be a civilization that adds beauty, knowledge, and wisdom to the cosmos, rather than one that squanders the gift of consciousness. The question that began our journey tonight, are we really the first advanced civilization, has led us through explorations of deep time, lost knowledge, underwater mysteries, and cosmic possibilities. It has challenged us to think beyond our assumptions and consider perspectives that stretch across billions of years and vast scales of space and time. But perhaps the most important insight from our exploration is that the question itself reveals something profound about consciousness and intelligence. The very fact that we can ask such questions, that we can wonder about our place in cosmic history, that we can imagine possibilities beyond our immediate experience, demonstrates the remarkable nature of conscious awareness. We are the universe becoming aware of itself. We are cosmic matter organized in such a way that it can contemplate its own existence and wonder about its origins and destiny. Whether we're the first to reach this level of self-awareness on Earth or not, we're certainly among the first in cosmic history to achieve such consciousness. This realization brings both wonder and responsibility. Wonder at the magnificent improbability of consciousness emerging from unconscious matter. Responsibility for using this consciousness wisely and contributing positively to the cosmic story of intelligence and awareness. As we consider the possibility that other civilizations might have preceded us on Earth, we're really asking what consciousness can accomplish, given time and opportunity. We're exploring the potential of intelligence to understand and transform the world around it. We're wondering about the ultimate possibilities and limitations of aware beings in a universe governed by physical laws. The search for earlier advanced civilizations is thus part of a larger search for understanding about the nature and potential of consciousness itself. It's an exploration of what it means to be intelligent, aware beings in a vast and ancient cosmos. It's an investigation of our responsibilities as conscious participants in the universe's ongoing evolution. Whether or not we ever find definitive evidence of earlier civilizations on Earth, the search itself is valuable because it expands our understanding of intelligence and challenges our assumptions about our place in cosmic history. It reminds us that consciousness is both precious and fragile, both powerful and vulnerable. Most importantly, it reminds us that we're part of something much larger than ourselves, or even our species. We're participants in the universe's ongoing experiment with intelligence and consciousness. We're contributors to the cosmic story of awareness and understanding. We're temporary focuses of the universe's capacity for self-reflection and self-directed evolution. This perspective gives meaning and purpose to our individual lives and to our collective efforts as a civilization. We're not just trying to survive and prosper for our own sake. We're contributing to the universe's understanding of what consciousness can achieve. We're helping to answer fundamental questions about the nature and potential of intelligence in the cosmos. The question of whether we're the first advanced civilization on Earth has taken us on a journey through deep time and vast possibilities. It has challenged us to think beyond our immediate experience and consider our place in the larger patterns of cosmic evolution. It has reminded us both of the magnitude of what we don't know and the wonder of what we do know. But perhaps most importantly, it has reminded us of the precious nature of consciousness itself. Whether we're the first to achieve advanced civilization on Earth or the latest in a long series, we're certainly among the first conscious beings capable of contemplating our own existence and wondering about our place in the cosmic story. This awareness brings both privilege and responsibility. The privilege of being conscious in a universe that spent billions of years creating the conditions for consciousness to emerge. The responsibility of using this consciousness wisely and contributing positively to the ongoing cosmic experiment in intelligence and awareness. As our exploration draws toward its close, we're left not with definitive answers, but with expanded perspectives and deeper questions. We may never know for certain whether we're the first advanced civilization on Earth. The evidence is fragmentary, the timescales are vast, and the challenges of preserving information across geological time are immense. But the search itself has been valuable. It has opened our minds to possibilities we might not otherwise have considered. It has challenged our assumptions about the uniqueness of our own development. It has reminded us that intelligence might be far more common and diverse than we typically assume. Most importantly, it has helped us understand that we're part of something magnificent and ongoing. Whether we're pioneers or followers in the development of consciousness on Earth, we're certainly participants in one of the universe's most remarkable experiments. We're conscious beings in a cosmos that has spent billions of years creating the conditions for consciousness to emerge and flourish. This realization gives depth and meaning to our efforts to understand ourselves and our place in the cosmic story. Every question we ask, every discovery we make, every moment of wonder and understanding contributes to the universe's growing awareness of itself through conscious beings like ourselves. The question of whether we're the first advanced civilization on Earth has led us through explorations of ancient mysteries, underwater realms, cosmic possibilities, and the nature of consciousness itself. It has reminded us that we're part of a story much larger and older than our individual lives, or even our species. Whether we're the first chapter or the latest chapter in the story of intelligence on Earth, we have the opportunity to make our contribution as meaningful and positive as possible. We can choose to be a civilization that adds wisdom, beauty, and understanding to the cosmic experiment in consciousness. In the end, that may be more important than whether we're first or not. What matters is what we do with the consciousness we've been given, how we choose to explore the possibilities of intelligence, and what we contribute to the universe's understanding of itself through our awareness and our efforts. The cosmos has been patient with its experiments in consciousness. It has provided billions of years for intelligence to emerge and develop. It has created countless opportunities for aware beings to explore their possibilities and contribute to the ongoing story of cosmic self-discovery. We are among the beneficiaries of this cosmic patience. We are among the experiments in consciousness that have succeeded in emerging and beginning to understand our own nature and place in the universe. Whether we're the first or the latest doesn't change the magnitude of this achievement or the responsibility that comes with it. As consciousness continues to evolve on Earth, and possibly throughout the cosmos, we have the opportunity to be part of something that transcends our individual limitations and connects us to the deepest patterns of cosmic development. We are the universe becoming aware of itself, and that awareness brings both wonder at what has been accomplished and responsibility for what might yet be achieved. The question of whether we're the first advanced civilization on Earth will continue to inspire exploration, research, and wonder. It will challenge new generations of thinkers to expand their perspectives and consider possibilities beyond their immediate experience. It will remind them, as it has reminded us tonight, that consciousness is both a cosmic achievement and a cosmic responsibility. Whether we find evidence of earlier civilizations or not, We remain conscious participants in the universe's ongoing experiment with intelligence and awareness. We remain contributors to the cosmic story of consciousness, exploring its own possibilities and potential. And in that participation and contribution, we find both meaning and motivation for our continued exploration of the mysteries that surround us. The universe has been working for billions of years to create conditions where questions like ours tonight can be asked and explored. We are among the first conscious beings capable of contemplating our own cosmic context and wondering about our place in the vast story of intelligence and awareness. That alone makes our existence remarkable, regardless of whether we're the first advanced civilization on Earth or one of many. We are conscious beings in a universe that has achieved consciousness, and that achievement deserves both celebration and the careful stewardship of wisdom and responsibility. As we conclude our journey through this profound question tonight, we're left with a deeper appreciation for the mystery and wonder of consciousness itself. We may never know definitively whether we're the first advanced civilization on Earth, but we do know that we're conscious participants in one of the universe's most remarkable experiments. That knowledge brings both humility about how much we don't understand and confidence in the importance of our efforts to expand understanding through continued exploration, research, and wonder. Whether first or not, we are conscious beings with the capacity to contemplate our existence and work toward a future worthy of the cosmic investment in intelligence and awareness that brought us into being. The question of whether we're the first advanced civilization on Earth remains open, inviting continued exploration and wonder. But our consciousness itself is not in question. We are aware beings in a universe that has achieved awareness through us, and that remarkable fact gives meaning and purpose to our continued participation in the cosmic story of intelligence, exploring its own infinite possibilities.